and then we remove it, and if it hasn't already been used, or if we decide not to add it if it's already been added, and we display, we should get the same order, right? Since I added the A first, A better be the first one.
That's not in order of queue, it's just like a web, the letters are like all 4 points.
So the next element we're going to remove is going to be the B. The next one is going to be the E.
So we just randomly pick those numbers?
I mean, if we have the A here, what's the next two elements that are going to go onto our queue?
He said you check.
But actually, if we go left first, this is first, this is second,
Going counterclockwise.
third, fourth.
So do you only grab one, right?
So in this case, though, we add the D first. So notice the D was
The
coming
D
up
was
next.
added.
And then the B got added. And then there's nothing up here.
Then what about sideways change?
So then,
Sideways change.
Yeah, how do you get to
So
J?
if
You have 1, 2, 3, 4, like, spots like that.
where do you,
See, that's what I was thinking, and then you added the J to throw me off, and now, okay.
How would you do that, though?
And
Check all 8 directions?
Or any number, just simply go through, maybe the next pointer is actually an array of pointers, and you simply go through the size and add it. That's pretty standard graph traversal. That's called, what is that called, by the way? Steve? What is it called? Depth first search, exactly right.
so,
No, I'm wrong. What is it called?
At first,
It's kind of a brute force, but it's bred first. Is it?
it's not depth. Must be.
How is this spreading out? What's kind of
Hands
weird
down,
is we started with
nerd.
A, right? And then we went to D, but then we jumped over to B.
yeah, I don't get it.
Isn't that weird? So it
must
spreads
be
out
on something
from
else.
our point. And the next one is going to be
Yeah.
C.
See, you've got a touching A, so it starts down, left, right,
And if
up.
you think of this as a drop of oil in the water, it spreads out like that. How does depth first search?
If it was depth, it would go in one direction until it can't anymore.
Exactly right.
Is that
Yeah.
right? And then try another direction.
All right, let's look at that.
Depth first.
That's depth first. Yeah. Keeps going until it can't anymore, and then
the
switches
Windows
directions.
screensaver.
Never heard of that.
Well, these are two uses for
Selfie.
what if I have a stack? And I add my first element, A. Okay? And then as long as my stack's not empty, what am I going to do? I'm going to remove A. Maybe it's been marked as it's been used already. And then I'm going to add to my stack what?
D.
Its children, which would be to the left, nothing, down. And then, what else?
B. To the right.
To the right.
B.
Now we're done with A. Or maybe we write out. Yeah, I like writing out the content. And maybe if you want, we'll mark these as being added, so we don't have to, so it doesn't become real tedious and take a long time.
So at this point, we already displayed A.
We've got A displayed so far. Now we just repeat the process. So we're gonna remove B now. It's kind of interesting, right?
While also printing it?
Well, what did we do first when we removed A? We found the,
Children.
went to the left, and there's an A there, but it's already been used, been added. We go down, C. So what do we have to do with C? And now we're gonna go to the right. This one's new, so we're gonna add I. Well, let's find out. And how about up? There's nothing up there. So we added the C and the I. Now we display B.
Oh, no, so that's the G, then it stops, and this is the.
Okay.
Now we look at I, right?
So we repeat the process again, which is kind of interesting because D was like the first guy to get added. Now he's got so many people ahead of him. Now I gets taken care of. So we've moved from A over here to B, right? And now where are we? To I. And so we look to our left, B's already been added. How about H? And what else?
You said I's been added?
Well, here we've removed I. So when we look to the left, B, that one,
You get
did I say? Yeah. And
That's
I
why I'm
has been
recording
added.
it.
You get this?
I's been used already. Yeah. So, but we're still acting on it. We're still looking to the left. We're looking beneath H.
Oh, this is before we print it.
Yeah, we have to do that. Now we look
Put
to
up
the M.
YouTube.
That's gonna be added. And then we go up, nothing's up there. And so we see how this is moving? Boom. Now let's pop the next element. It's an M. So we started over here, but when we use the stack to store our values, our nodes, we're moving far away. Every step we get further and further away from where we started.
So it's zigzag.
It'll eventually zigzag or something because it's going to hit a wall. But when we were using a queue, we went to this guy first, and then we went to this guy. And then we went here, and then maybe here. See, we're sort of making rings around where we're starting at. And that's simply because we're using a different type of data structure to hold our data. All right? So what we're going to have on the final, this will be a very nice, it shouldn't take you more than 10 minutes to write this question, is we'll have a graph. This is actually a graph. But we're going to have some kind of shape of nodes like this, and we're going to say each node can have left, right, up, or down. And we're going to start with the upper left-hand corner, or start at some point. We're going to add that to our data structure. Okay? We're going to mark it as being added. Okay, and now we're going to repeat until our data structure is empty. All right? And what are we going to repeat? We're going to remove the element from our data structure, add any children that it has in order, right, down, left, up, or up, left, down, right, whatever order we decide on, if they haven't already been added. And then we're going to display the contents. All right? So there won't be any, you won't actually, from this point on, if you took some notes, that's great. You don't have to do anything between now and next Tuesday, as far as this is concerned, because we'll have the list of instructions. Follow this order and display it, and see what happens. Question?
Can, you don't have to go slowly. Can you go through the queue one more time really quickly?
With the cube?
Yeah, just quickly.
Okay, so here,
Like, you don't have to do it
we're going to
slow.
use a cube instead. So what's the first thing we do? We're starting here,
Right.
so we add that to our cube.
Right?
And we're going to mark it.
Okay.
Okay, so now, as long as this is our repeat part, this is where we're going to repeat until when?
So it's empty.
Until the structure is empty, either a stack or a cube. So the first thing we do is remove an element. It's empty now, but we don't actually check. That's at the top of the loop. We've got a few things to do. So because we removed A, what do? We check left, down,
Which is a D, yeah.
D, so let's add that. Check to the right, which is a B, we'll add that. Check up,
Nothing.
nothing there. And now, display the content. And repeat. Move the D. And we're here. Mark it. Oh, it's already been marked. That's one of our steps. We check upwards. We add it.
No.
We start
Then add
left.
it. Go to the left. Don't add it. Go down. There's nothing to add. Go down. E.
Yeah.
That one hasn't been added yet. Let's add that one. See, but note, we're coming in this direction
Right.
when we add. And then we go to the right. And that one hasn't been added yet, so we'll add that guy. Okay. Now that we're done, let's display.
So what would you display?
So how is this different? So now we've gone from A to D, right? Now we display our next one, or remove our next node. We jump over to this side.
Got it.
And how far away from A, is D? It's one step, right?
Yeah.
And how far away is B?
Last step.
It's also one step. So before we get on to something, how far away is E? 2 steps. And G is like a bunch of steps. Before we get on to 2 steps, we have to finish all of the what?
One step.
The 1-step ones, because we're adding those at the very start. Okay, so we have B. Now, do I add A? That one's already been marked. B is marked. How about C?
Already. It's already been marked.
It's already been marked because it's been added from D. How about I?
We added that.
Yeah, that.
That one has to be added. Alright? And then go on up. And display our value. So the only thing that's going to differ in our process is whether we use, what, a stack to store our data, our nodes, or a queue.